Limit the range. Now that we're able to cast a spell on the grid, it will be nice to also be able to limit the range of that spell. Otherwise, any unit could cast any spell from anywhere to anywhere, and that's not what we want. So today we're gonna add the range system, and we're gonna add a few patterns in there to be able to be creative with the range of our spells. So let's get to it. But before doing the range of the spells, there's a little something that I want to change in one of our blueprints. So in the blueprints right here, I have actually it is in the grid pathfinding blueprint. So BP grid pathfinding that I'm going to open right here, and I'm inside the function. So get neighbor indexes for triangle. We have that little bit of code right here that checks if the triangle is facing up or down. That bit of code is used multiple places in this blueprint. So if I do a find reference, I can see that everywhere that I'm using the isInt_even function. So here, 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 and here, I'm also doing the same thing. I'm checking if the triangle is facing up. So what I'm going to do is just take that little bit of code and move it into a function library. That way, if we want to use that function somewhere else in the project, which we will do today because it's going to be helpful for us when we generate the range for the triangle grid, we're going to be able to call that function instead of duplicating that bit of code here and there, here, and here, and build multiple places. So what I'm going to do is just move that inside a function library. So I'm going to go back here. The function library I'm going to take is just the BFL tile data that I have just right here inside the grid. So let's open that one, and I'm going to create myself a new function for it. Here we go, here is my function. So I named it is triangle tile facing up because that's exactly what it is doing, is checking if the triangle tile is facing up or not. For the logic, I copy pasted the code that we already had before, so I'm just breaking my index that I receive as input to access both int, comparing them to make sure that both of them are either even or odd or equal or not, and then I'm returning the result at the end. I also made sure that the function is a pure function, so it's easier to call everywhere else. And now to go call it, I'm gonna go back in the grid pathfinding, and I have all my isInt_even right here in the find results. So I'm just going to start with the first one, this one right here, and I'm going to replace the code by this new function, just like that. So we can delete what we had before and replace it by the isTriangle tile facing up. Now I'm gonna do the same thing for the other one, so I'm gonna go here, which is the second instance, so we can connect it like so instead of the previous code that we had. Then we can go inside the next function right here. That one is a little bit more complex because both x and y are not in the same variable, so we have to split the pin and just connect them like so. And now we can connect the return like that. Okay, now we can go to the next one, which is this one right here. So we're gonna do the same thing, but this time we can simply connect the variable just like that and replace it like so. And finally, we have the two last ones which are here. So we're just gonna do the same thing. Actually, it's using the same index as the previous one. So I can just paste it like so and connect it to the index just like that. So now we replaced everywhere that the code was using that bit of code by the new function. Perfect. Well, now it's time to do the spells, and we're gonna start by creating ourselves a new enum and new structures for the new data we're gonna use today. So I'm gonna go in my spell utilities right here and create myself a new enum and a new structure. So blueprint enum and then blueprint structure. Here we go. I named the enum spell range pattern because it's going to be a list of all the patterns we're gonna do today to determine the range of our spells. And for the structure, I named it s_spell_data_cast. It's going to contain all the data required by the code to know if the unit can cast the spell and all the other informations that are useful for it. And now let's open both of them. And here they are. So for the enum on the left, I added a bunch of new elements, which are, the first one is the non-element. So when we don't have any range, we'll use that pretty much just to debug, but whatever. And then we have the line pattern, so just in a straight line, diagonal, so it's a diagonal, obviously. Half diagonal, that one is a little bit more special. I'm going to tell you later why I'm using that one. I have the star pattern, so a combination of both the line and the diagonal. Then we have the diamond, which is more or less the same thing as a movement range. And then we have the square pattern. We have more pattern to do in the future, but I think that's good enough for today. It's going to be actually a long list already. So that's what we're gonna do today. And then for the structure, I first added my range right here. So my range pattern that we just created on the left. And then I have my range minimum and maximum, which is an endpoint. That way we are going to be able to modify the range of the spell and really decide if we want to be able to only cast it far, close, and what the range is in between. So that's for the two new structures and enum. So we can close both of them now. And we're going to add this new structure inside the other structure. So the S spell data. So I'm going to go add it in there right here. Just like that. So now I have my cast variable right here, which is the new structure we just created inside this structure right here. And now since it is inside that structure, it means that we are also going to be able to modify it inside the data table. So I'm just going to close this one and go inside the data table to set the default value for the test spell that we're going to use today to test the range. So here I have my range pattern that I can select. I'm just going to select, let's say, the diamond, doesn't matter. And for the range minimum and maximum, let's say 2 and 5. So it's going to start at 2 and end up at 5. Here we go. So now we have all the variables we need for the range of this spell. So good. Now we can close this and go to the next step, which actually also require to go modify an enum. So since we want to also be able to display the range of the spell on top of the grid, we're gonna need a new tile state to be able to display a new color on top of the grid. So what I'm gonna do is go inside my grid in utilities right here and open the eTileState enum. In there, I will add a new state. So there is a spell range state. And now I'm going to save it and go set the color inside the grid mesh inst. So here I have my make array, so I can add a new pin at the end. And I'm actually not going to make it the last one this time because I want the reachable to be less important than the spell range. So I'm just going to make it in that order. So is spell range first and then the reachable. And now I'm just going to change the color of the spell. And I think I'm gonna go with this one. It's not pretty, but I think it's going to be good enough. So a shade of orange. Here we go. Now we can compile and close this blueprint. And now it's time to go create the action we're gonna use today inside the debug menu. So I'm gonna go in my action and I'm actually going to go in the action of the grid and create another child blueprint of the action select tile and unit because we want to be able to select a tile and then calculate the range from that specific tile. So we're going to create a child blueprint of that one. So create a child blueprint class. I'm going to name it action underscore select tile and unit and show spell range pattern. Oh, that's a long name. And now I'm just going to also move it inside the combat folder because it's related to the combat and not really the grid. So let's move it there. And now let's open it. And for this action to do its job, it's going to need to know the cast structure of the spell we are trying to cast. So if we are trying to cast a spell with a square range, it's going to know it. So that's why we are going to create a new variable of type of the spell data cast that we created. So spell data underscore cast right here, which I'm just going to rename it cast. And now that we have the variable we need, it's time to do the function side of things. So I'm gonna start by overriding the execute action function that we have right here. And then we have to make sure to call the parent. That way it's going to select a tile for us. Since the parent class of this action right here is the action select tile and unit right here in the top right corner. And now, just so it's a little bit cleaner, I'm just going to create myself a new function for the logic of this specific action. So I'm going to name it show spell range pattern, just like that. And now I'm going to call it in my execute action after having executed the parent function. So we're going to do everything related to the spell range inside that function right here. But before doing that, I think it would be better to go add the button in the widget right away. That way we are going to be able to test it if we need to. So let's go in the debug menu to add it. So debug menu, actions, and I'm actually going to duplicate one that has a combo box in there just so it's going to be simpler to code. So let's duplicate button action set tile type right here. And I'm going to rename it button action show spell range pattern. And now we can open that one and do the logic of the button first. And here in the designer side, I didn't change much. I just changed the text written on my button and also the left click action right here. It is the action select tile and unit and show spell range pattern, which is the new action we just created. And for the right click, we don't have anything because we actually don't need anything for the right click for this action. And for the second one here, I just rename my combo box and we're going to do the logic inside the graph. We're going to populate it inside the graph. So let's go in there to do it first right here. And as usual, it's super simple. We just have to replace the for each loop with the new enum. So we have the new enum spell range pattern that we can connect instead of the previous one. So let's connect it like so. Let's connect the completed also and delete the previous one just like that. Here we go. So now the combo box should be populated properly. Great. Oh wait, I just realized that I forgot to add something in the designer. So in the designer right here in the vertical box, I'm just going to add a spin box with name for a vector 2D for my spell range right here. So now I have my new spin box at the end. I named it range. Here we go. Minimum, maximum 0 and 1000 doesn't matter. And then the max slider 20 doesn't matter. Also, the default value I made it 1 and 5 just so we have a default range. Min max digit 0, 0, always snap true, and the data is going to be 1 because we can only increment the range by 1 at a time. Here we go. So now we can actually go back in the graph for real and do the logic that is passing the values to the action right here. And here, first thing I'm going to do is the visibility of my spell range spin box that we just added. So I'm going to add my spin box right here and right there at the bottom. So it's hidden or visible depending if the action is selected or not. And then for the rest right here, I'm not going to need anything for the right click because we're not going to do anything for the right click. And for the left click, I'm going to delete the cast and replace it with a cast to the new variable that we created. So the new action actually. So the action select alien unit and show range pattern. And what we're going to do is set the cast variable inside that action. So we can just break it, make it right here. So we can set the values just like that. For the range pattern, I'm gonna just delete the old conversion node and replace it like so. And for the range min-max, I'm going to use the value inside my spin box with name. I'm gonna take the value and connect it. It's going to convert it from a vector 2D to an int point for us. Well, here we go. So now we have everything to be able to test it if we need to. But first we need to add the button in the widget. So I'm gonna go back in my debug menu, in my tabs, and go add it inside the tab spell here. So I have my tab spell. I'm going to search for the new button. So show spell range pattern, which I can add to the vertical box and add it a little bit of padding. Here we go. So now we're done for real. Let's compile and close the widgets and the button because we're not gonna need it. And now we can go do the action. But actually, for the logic of the action, we're gonna go create a new function inside the combat system because that's the combat system that is aware of all the tiles and if they are targetable or not, if the units are on them and things like that. So let's go in the combat system to create that new function. So combat system and create ourselves a new function right here. I named it get spell range and we are passing it two things. First, the origin index. So where are we on the grid when we are trying to generate the range of the spell, and then the cast structure of our spell. That way it's going to contain all the info we need to generate the range. And now for the return, I'm just returning an array of indexes, which is the array of endpoint that contains all the range of our spell. Now we can go back in the action, select tile and unit and show range pattern to draw the pattern on the grid. And that's how it goes. So first we have to clear the state from the tiles. So we have the previous tile that we highlighted. We have to clear them. So clear the is spell range state. Then we are just making sure that the selected tile is valid because we clicked on a tile. We want to make sure that it is valid before trying to draw anything. Because let's say if we deselected the tile, it's going to pass an invalid index and we don't want to have any errors right here. So we're just making sure that the selected tile is valid. Then we are getting the spell range from the combat system, passing in the selected index and also the cast data that we have. And finally, we just received all the range indexes. We just have to draw them on the grid. So we can add the new state to the tile. So add the is spell range state to all those tiles, just like that. And that's it for the action for now. Now we can go inside the combat system to do the logic of the get spell range function. But actually, this function is going to be super complex and I don't want to have a bunch of noise inside the combat system. So what I'm going to do is create myself another function that is going to do pretty much the same thing without any grid dependencies and things like that. But it is going to be inside the function library of our spells. So I'm going to go back in entry. I'm going to go in my spells right here. We have in utilities, we have the BFL spells. So I'm going to go in there and create myself a new function to do all the math stuff that we need to do to retrieve the indexes that we need for the spell range. I named the function getGridIndex from pattern and range and I'm passing it 4 inputs. The first one is the origin index, obviously. Then this function is going to need to know what is the grid shape. So the second one is the grid shape because the calculus is going to be different if we have an hexagon grid, a square grid, a triangle grid, and actually that's a pain, but we'll see pretty soon. And then we have the range pattern and the range minimum and maximum, which I actually splitted because instead of passing the cast completely, the structure completely to this function, I'm just going to pass the range pattern and the min max because we're going to add more things in the cast structure in the future. Let's say if the spell requires the line of sight or different things that this function doesn't need to know. So that's why I'm splitting it. So we have 4 variable right here that we have on the right also. And I'm also returning at the end the range indexes, the same way we did in the combat system. So now I'm going to go back in the combat system actually to call this function right here. So instead of connected like so, I'm going to replace it by the new function. So the get indexes from pattern and range. And for the 4 variables, it's simple. The origin index, simply the origin index. Then the grid shape, we can just get the grid shape from the grid, the range pattern, and the range min max. We just have to get the cast and break it to have access to those 2 variables. Here we go. So now we are now calling this function instead of doing all the logic inside the combat system itself. So now everything else that we're going to do today, not everything, but most of it is going to be inside the BFL spells. And we're actually going to create a bunch of functions and a bunch of things. And actually this part is going to be a little bit special because there's a lot of code, like a lot of code. Like I would rather do it in C++ type of thing. There's a ton of code. It took me hours to just align things properly and make it somewhat pretty. So what I'm gonna do is, instead of just going through all of that and explain it to you and whatever, I'm just going to paste all that code online and give you a link. So it's going to save you a ton of time. And we're gonna come back here afterwards just to go through all the functions and everything and just explain them to you. So you should have a good idea on how they work and everything like that. But for the most part, it's just adding numbers together. So nobody cares about that. I don't. So let's skip that. And I'm going to come back here in 2 minutes. And I'm back. And here I have all my new functions. So I have a bunch of them. And when I'm in game, I'm able to draw all the patterns that I want. Great. So I guess we're done for today. So I'm going to see you. Nah, just kidding. I'm going to share with you all that stuff right here. I'm not going to go through it in Unreal, but actually I'm just going to do it in Blueprint UE right here. Because right here I created a bunch of functions for you. It's all the same function that I have in Unreal, but you can open all of them one by one and just copy paste the code if you want to, or if you want to see it in the video instead. I'm just going to quickly go through all the functions in full screen, I think, in the video, just to make sure that even if the link breaks in the future for this website, we're still going to be able to reproduce the code in the future. So I'm just going to go through all the functions and let you the time to copy all that if you need to. Okay, bon, now let's go through all of that together quickly just to explain you how it works. First, the entry point is the get index from pattern and range, which is the function we created together. So that's pretty normal. We know where it's coming from, so good. That's the starting point. And this function looks pretty big, but it's actually pretty simple. It doesn't do much other than just switching on the range pattern just to decide which function to call and then call the appropriated function. So we have all the different patterns here. So we have the line, diagonal, half diagonal, star, diamond, square, etc. So if we have other patterns in the future, they're just going to be added at the bottom right here. And then we can simply return the output of those functions at the end of this function right here. So this function is not doing anything. It's just calling the right function to obtain all the right indexes. And then, as you can see, all the pattern functions are formatted the same way because they are all doing the same thing. They are just adding numbers together to give us back the indexes. So if we go, let's say, in the line function right here, at the beginning, we're just looping through the range. So we are generating the tiles for all the range. So if we start at the range 0 and go all the way up to the 5 range, we're going to generate all the tiles in between. And then depending on the grid shape, we are doing different maths here and there just to generate the right indexes. And then at the end, we are just returning the indexes. So that's all that this function does. And it's actually the same thing for all the other ones. So looping through all the indexes, depending on the grid shape, generating the tiles indexes. And same thing for all the other ones. Right here, some are simpler than others, and some are way more complex. Like that one, oh, actually, diamond one is the worst. But yeah, some are more complex, some are more simple, but in the end, they are all doing the same exact thing. And about the functions that are a little bit different, so let's say the half diagonal and the stars, they are a little bit different than the others. So that one, the half diagonal, is simply dividing the range by 2 before calling the diagonal function. So it's really just the half of the diagonal function. And actually, the only utility of this function is inside the star pattern, because we are never going to want to divide the range by 2, I guess, in the real game. But inside the star pattern, I think it looks better when the diagonals are halved for some of the patterns. So if we are using the square shape, it's fine. We can use the real diagonals. But when we are using the triangle or the hexagon grid, I think it looks better when the diagonals are a little bit shorter. And you'll see in game what I mean. But yeah, we can test that together, and you can remove that condition if you want to. Always use the real diagonal or always use the half diagonal. It doesn't matter, you can choose the one you prefer. But yeah, so for that pattern, the pattern star, we are simply getting the line pattern, so the indexes for the line pattern, and on top of that, we are adding the diagonals, so it's going to generate a little star. It's as simple as that. And finally, we have one last function, and it is the offset index array function right here. And the only thing it does is to take the array that we receive as input and just add an offset on all the indexes that are inside the array. And the reason why we are doing that is because all the get pattern functions, all of them are just generating the indexes around the index 0. So -1, -2, +5, +6, whatever, but they are all around 0. But in that case, in our case, if we are selecting a tile on the grid, we want to offset that range. So we are generating a range around 0. We want to place it where we are on the grid, so at the index that we are using to generate the range. So that's why we are using this function, and we are calling it at the end of the get index from range and pattern, right here at the end before returning it. So we are getting the pattern around the index 0, and then on top of that, we are just adding an offset just to align it properly on top of the grid. Otherwise, it's always going to be around 0, so that's not what we want. So that's why we are calling this function right here at the end before returning. Okay, now we should be able to go test it in game, but first I noticed there's a little bug in our user interface, the button we created today, so I'm just going to go fix that real quick, so it's going to make our life a little bit better. So I'm just gonna go in the button right here, and what I didn't do is to implement the event for the range. So when the value changes on the range slider, it doesn't affect the result. So I'm just going to implement that event in the top bottom right corner right here, and then we can just collect it like so, like the other ones, just like that. So now it's going to update properly. So now I'm going to go back in game, press play, and test my spell. I'm actually just going to make it on a tactical grid just so we can see better. And now if I try to draw my range, we can see that we have the line, and if we change the range pattern, we can see that it affects the result, just like that. Okay, great. And now for the diagonal, this is how it looks. Okay, my range is a little bit big. I'm just going to bring it down a little bit. Now I have my half diagonal, which are just half of the diagonals. The star, well, it's a star, it's pretty simple. The diamond, here we go. And it looks even nicer if we don't have like the inner diamond. So we can see like, yeah, we can have only spells that are targeting far away tiles and things like that. So that's nice. And then we have the square, which looks a little bit like this. So good, this was for the grid of a square, the square grid. And now let's say we are trying for the hexagon grid just to see if it does the same thing. So I'm just gonna start with the beginning. So these are my lines. I'm just going to reset my range so it's a bit cleaner. Here we go. So these are my lines. I think these are lines for the hexagon. I don't know. You can decide what you want to use for lines. Now these are the diagonals, so we are skipping every other tile just because that's how the diagonals are, I guess. Whatever. And then we have the alpha diagonal, which are just the alpha, and then we have the star here. And we can see that this is why I want to use the half diagonal for the star, because I think it looks a little bit better with the star with the diagonals a little bit shorter. Otherwise, like the diagonals will be all the way up here, I think, something like that. So I think it's a little bit far. Let's say if I reselect my diagonal, we can see the difference. Oops, no, this is the line. So the diagonal goes all the way up here in the corner, and then if I switch back to the star, we can see that it is shorter. So I think it will be weird to have the diagonal too long for the star pattern, for the hexagon, and also the triangle. So that's why I'm using the alpha diagonal for the star. Then, well, okay, this is the diamond pattern, which is interesting. And the square, well, it's a square, I guess. It's close to a square. And then finally, we have the triangle. So I'm just going to go switch my grid shape for the triangle grid. Here we go. Okay, so we have the square. It's a square. It's nice. The diamond, it's pretty nice also. And it also flips both the direction, either if we are in the middle of a tile that is looking up or down. So it affects the diamond pattern. And then we have the star, which is, well, okay, it's ugly when we're close, but in far range, it's a little bit better, I guess. It looks nice, it looks nice, and this is the same thing. The diagonals will be super long on the other axis if we are not using the half diagonal. So this is the half diagonal, and then we have the diagonal, which are super long. So yeah, that's why we are using the half diagonal for the star. I think it looks better. And finally, we have the line that looks a little bit like that. So these are all the range pattern that we have in today's video, and in the future we can add more if we want to. But for now, I think it's good enough for most of our spells. So we're gonna only use those for a little while, I think. And now there's one other little thing that I want to change in the user interface, because right now, if we, let's say, change a value in this, we have to select a new tile. Same thing for the range. We have to always select a new tile so it applies. So we're just gonna make sure that it applies automatically when we are changing something in the user interface. So it's going to be simpler to test. So I'm just gonna go back in there to do that. And to do that, I'm just gonna go at the end right here when we are applying the cast. And right after applying the cast, what I'm gonna do is first adding a little delay, just so we are not regenerating the grid, the pattern every frame, because if you remember the spin box, this event is called every frame, so we don't want that. We don't want to regenerate the grid every frame, otherwise it's just going to be super costly in performances. So that's why we are adding a small delay, and then we are just simply calling the function show spell range pattern. So it is going to re-update the spell range pattern on the grid. So now that should work, so we can go see how it works in game. Here we go. So now I have my diamond pattern selected, and I can tweak my range just like so. So we can see the result in real time, and it is the same if we switch between different patterns. So we can see that it applies automatically. So great, that works perfectly. And actually, while we're here, I think there's another action that we could use this same technique on, and I think it is the select find path, I think. Yeah, so this action is updating the reachable, but if we change the path length, we can see that it doesn't apply automatically. Same thing if we include the diagonal or the flying unit. We have to select another tile so it applies. So I'm just going to do the same technique for this action also. So I'm just going to stop and go inside the button action for the find path to target. So which one it is? Find path to target right here. And then in the graph, I'm going to go at the end right here, and I'm going to do the same thing. So adding a small delay right here at the end, small delay. And then once that's done, we're gonna generate the reachable just like that. So we can just connect it right here. And that should do the trick. So now I'm just going to compile and go see in game, go back in tactical mode, then in the pathfinding I can select and find the path, so just like that. And now if I change my length, here we go, we can see that it updates automatically. Great. So now I can include the diagonal and everything, and it updates right away. Great, that works. And now the next step for today's video, it is to apply the range on our spell, because right now we can see that if we are using that action right here, the show spell range, it works. We can select the range and everything. But if you remember at the beginning, we changed something in the data table, so the spell also has a range. But right now it doesn't work. It doesn't apply the range on the spell, and also it doesn't limit the range possibility of attack. So we can still attack all the tiles on the grid, so that's not good. So what we're going to do is apply the spell range on top of our spell, and that's the next step. So let's go do that. And as the first step, I think it will be nice to just draw the tiles on the grid. So we're going to do that inside the button action cast spell, because right now we're simply selecting a tile right here. In the button, we are only selecting a tile and a unit. But what we're going to do is replace the left click action for the select tile and unit and show spell range, the new action we created today. And now we can go back in the graph just to assign what we want to draw in that spell. So right here in the action left click, we're going to do the exact same thing we did in the button action show spell. So everything that's in there right here. So we're going to cast, and then we're going to set the cast variable, wait a delay, and show the spell range pattern. So I'm just going to copy all that and paste it right here. We're not going to make the cast the same way, so I'm just deleting that, and then we can reconnect everything right here instead of what was there before. Here we go, that's better. And now just to set the value of the cast right here, we're gonna use the function inside the function library. So get spell data from spell, just like that. We're gonna connect it like so in between right here, and we can use the spell data to set the cast. So we can split the spell data and connect the cast just like that. And now for the spell, well, we're gonna use the spell that is selected in the combo box. So we can connect it like so. And now just like that should be enough, so we can draw the tile range on top of the grid. So now let's go see if it works. Here we go, so now that works, great, and it is using the data from the data table. If you can see on the right, right here, we can change the values in the data table, and they are updating in game. So if I just change my pattern and reselect my spell, we can see that it works. Then I can change my range if I want to. If I reselect my spell, we can see that it also works. So it is really using the data that is inside the data table to determine the range of the spell. Great, but now there's one last thing to fix, and it is that we are still able to cast the spell everywhere on the grid, not only on the tiles that are in the pattern. So what we're going to do is just limit the possibility to cast the spell on those tiles. So we can't just cast the spell anywhere we want to. So let's go do that. And that's going to be inside the combat system in the cast spell function right here. We are getting the data, and then we're going to cast it. In between, we're just going to make sure that we are able to cast the spell on those tiles. So if target index right here is part of the range of that specific spell, well, we are going to cast it. Otherwise, we're not going to do anything. And that's as simple as that. So we are getting the spell range using the origin index and the cast structure of the data. And then from the range indexes that we receive, we are just checking to make sure that it contains the target index. And if so, we are casting the spell as usual. So now that should limit the possibility to cast the spell only to the tiles that are inside the range. So let's try that. And here we go. So now if I try to cast my spell outside of the range, we can see that it doesn't work at all. It doesn't do anything, and that's exactly what we want. We don't want to be able to cast a spell outside of the range, but inside the range it works. And now if I move my range right here, we can see that it also works, and we can move it everywhere. So we are not only able to cast a spell in the specified range. So great, that's exactly what we want. And I guess that's gonna be it for today. So I'm gonna see you in the next one. Bye bye!